This video is intended to help in your preparation for one of the fairly common basic technical questions you can get in a job interview. Describe what happens when you call up Yahoo News using TCP on your browser. Or you might hear it a slightly different way, like explain the process whereby TCP is used to render a web page like news.yahoo.com in your browser. The first thing to recognize here is that this is really not a question about whether or not you have figuratively crammed for the test by memorizing a step-by-step response for this particular question. The question really is more like this. Demonstrate that you understand the concept of the Open Systems Interconnection, or OSI model, and thus networking, such that you can competently perform appropriate troubleshooting without supervision should the need arise, which it will. And as a side note, if you use the term OSI model or DHCP or DNS in the interview, either use the full name or the acronym, but try not to use the acronym and then the full name. If there's a whiteboard available, the interviewer will often have no problem with you using it, so start out by writing out the 7 layers of the OSI model so that you can appropriately structure your response. You can remember them in the proper layer order using the mnemonic device. Please do not throw sausage pizza away. By convention, however, they're written in order of proximity to the user, like so. Don't sit there and bore the interviewer by defining what each one is. He or she will likely be confident in your ability to study the basics. What you're doing here is demonstrating that you have the functional skills that are necessary to contribute in a meaningful way in a real-world environment. However, since this is a preparation video, we are indeed going to go through each one. As we progress, think about what sort of follow-on questions the interviewer will ask in an attempt to further probe for understanding on your part. Don't get nervous or defensive about the questions. The interviewer is purposely trying to determine if your knowledge is rote and therefore superficial, or you are the real deal. Speaking of rote knowledge, don't ask for a copy of the OSI model because you will need to have the layers memorized. Why do you think that is? We'll answer this one at the end. So in the next few minutes, we'll go over the concepts behind answering this interview question, and it will be on you to determine how you want to tailor your answer to the question depending on what job you're applying for. So let's start with layer 7, application. This is just the application in use and will be the only layer a typical user will be familiar with. So you could set the scenario by saying, I'm using Chrome as my web browser, my OS is Windows 8, I'm at home on my wireless network on my laptop in front of my television set, and I type news.yahoo.com in my browser and I hit enter. Here's what happens next. So here we are with the application layer, and the application is just Chrome. You enter into Chrome, I want to look at news.yahoo.com. The presentation layer in this example is basically the application performing its role in translating user actions, with you as the client, that are easy for humans to follow, to those specific commands that the server, which is the hosting site of news.yahoo.com, can use to respond to your request. So the translation of your user input, I want to look at news.yahoo.com, will break down like this. As we diagram our URL, we start out with .com. This is the top-level domain, or root zone database, and it's used to identify which of the 13 tree-building nodes that build the hierarchy of the domain name system, which is covered later. So .com, .net, .org, these start the hierarchy of determining the mapping of IP address to the website news.yahoo.com. So altogether, we'll be asking to look up the IP address for this DNS, news.yahoo.com. Index.html is often the default name for root server requests like this. There's no reason to show it in the browser window, so Chrome does not do so. But this is the file you're looking for. And the DNS is returned that our URL starts with HTTP, which defaults to a port setting of 80. We'll use this port to access the server. And so the presentation layer has converted your application layer request to go find the IP address used for the server that is hosting news.yahoo.com and use to connect and download index.html on port 80. Let's move on to the session layer. The session layer is how the client and server will communicate unique attributes specific to that particular connection at that particular point in time. Often it will be time-bound and is extremely important when using secure websites or a website that requires a login. If you were to check your Yahoo email from this news site, you would be required to log in and a session ID would be created. One of the more obvious reasons to use the session layer would be to automatically log you off if you walked away from your computer without logging off. Moving down the stack, we get to the transport layer. This layer takes care of the actual transfer of data packets back and forth between the client, which is your laptop, and the server. So an example here, we are observing our packets heading out to the networking infrastructure and constantly asking, where's IP address so-and-so? I've been told this is where I can find file index.html on a server they are currently calling news.yahoo.com. The same principle applies on the return trip as the server asks, where is IP address other so-and-so? I have a file called index.html that they have requested. Moving on to the network layer. This is the layer you will spend the most time on. When internet networking was first getting developed, an internet protocol address system was used to uniquely identify each machine connected to the internet. The IP address standard is known as IP version 4. and is represented by 4 entries between the ranges of 0 and 255. When we talk about IP addressing, we often refer to the IPv4 standard because it's easier for us to visually grasp. In 2012, a new version of IP addressing was put into place called IP version 6 to address the problem of all of the possible IP addresses getting used up, which was known as IP address exhaustion. While IP4 had 2 to the 32nd power possible combinations, IP version 6 has 2 to the 128th power possible combinations. It uses a combination letter and number format. Rather than try to remember all of the DNS name to IP address mapping for each site, the early developers distributed a file called host.txt to participating domain name servers to do the translation. This wasn't scalable, so there is now a distributed system of domain name verification which takes the form of authoritative name servers, which can positively identify the mapping of DNS to IP address and name servers, who will pass along the mapping that they have received from authoritative name servers and stored for a period of time called time to live. So, in our example, we see that our Chrome browser has asked the name server used by our ISP what IP address is the appropriate one to use for news.yahoo.com. You can quickly verify this by using a CMD prompt on your laptop and entering ping news.yahoo.com. It looks like this. We enter in ping news.yahoo.com, and there's your IP address. In this example, my laptop requests the DNS to IP address mapping and receive this in response from a domain name server. If our ISP name server didn't know this information, they would ask another server, and then another, and then another until it either timed out or received the info it needed. We call this practice recursive name servers. So if we go back to the transportation layer for a moment, we now have an IP address to use to route our packets. The address passed to the network also comes with a port setting, and in fact both are needed to actually connect to the Yahoo server. In our example, Chrome assigned port 80, which is the default used for the HTTP protocol. The combination of IP address and port setting is known as site binding because a website needs both to receive visitors. So a good follow-on question for the interview: why are there port settings? Port settings are a way to improve the efficiency of a network by grouping transmissions that are similar together during transport. This concept is known as multiplexing. It was originally embraced as a way to make analog signal transmittals more efficient, but can apply in the TCP world as well. For example, say you host your web portal out of port 80 and your email out of port 25. You can throttle the data coming out of your port 25 to guard against spam compromise while having a more lax throttling on a port that you're expecting a much larger bandwidth load. So how about our client port setting in this example? Are we connecting to the Yahoo port 80 at the server's IP address using our port 80 at the source port? Most likely not. Typically a random port will have been assigned to our laptop making the connection to the server. So that could be another potential interview question as well. Here's another one. Do we have to use port 80 to access a website? No, it's not required, but if a website did not offer that as a default, all web browsers would fail to load the page. Sometimes during development you might see a website represented like so: news.yahoo.com, port 8080. This would be a website application that is using that port to connect. A quick note about default port settings for our example. If we route over to the Yahoo Mail component of the website, the browser would move us over to the port setting of 443, which is the HTTPS or secure protocol. So if one is secure and one isn't, how come all the websites aren't using HTTPS? If you get this question, the most common answer is 1. Cost. HTTPS is slightly more expensive to set up and administer. 2. Performance. There are sites like news.yahoo.com that would like your browser to cache and save images in perpetuity. This saves time each time you visit the site. Caching of content for long periods of time is not possible using HTTPS. This brings us to the data link layer. This layer is the sort of routine operating procedures that clean up issues in the transport layer. For example, say we made a connection to our website, but there was an issue. The data link makes sure that error messaging goes back and forth between the client and the server, such that there are communications of issues that might arise. So the client might be sending, "I send X, did you get X?" and wait for a response. Whereas the component routers and switches might be saying, "I responded with Y, did you get Y?" So this is not a true data link layer example, but say we didn't get these typical HTTP error codes in our browser. Instead, the browser just hung up or crashed. These type of messages that are critical to a data link have even started creeping into our day-to-day lexicon. You expected to know what these codes mean. And finally, the physical layer. This is just the hardware that you're using to pull up the homepage for news.yahoo.com. A savvy customer support rep once remarked that the first thing he liked to do when a customer called up with a website problem was to ask the customer to go down to their computer and disconnect the Ethernet or token ring connection and blow the dust off of it. The rationale was that dust would interfere with the internet connection. This wasn't the reason, and that's not true. He really wanted the customer to confirm that the computer was still plugged in, which often can be an anger-inducing question to lead out with. As a visual aid to this concept, here we see a clip from the 1996 movie Sling Blade, where Carl is troubleshooting a problem with a defective lawnmower.
It ain't got no gas in it.
By now we should see that the interview question is an extremely comprehensive one. You might like to compare it with this scene from the 1986 movie Back to School.
Well, Dr. Barbet, I suppose you're up first.
I have only one question for Mr. Mellon. In 27 parts.
At the start of the training, we discussed memorizing the names of the 7 OSI layers. Have you figured out why yet? Take, for example, the paramedic, or EMT, who's arriving on the scene of an accident. They have a standard troubleshooting process called ABC, which stands for airway, breathing, circulation. When the patient is potentially in trouble, these issues are often the first things to look for. So after you answer your question about what happens when you call up news.yahoo.com, your interviewer might ask a follow-up question like, tell me about what kind of problem you could have in the network layer, or what sort of things would you see that might tell you that you have a problem with your presentation layer? After the conclusion of this video, go back and look at the OSI model and come up with ideas for what could be causing faults in each layer of this scenario, as well as possible solutions to fix. We have provided an easy one to start, the physical layer. Say your laptop battery has died and this is causing a failure of the web page to load. What would you do to fix that problem? And so at the conclusion of the training, we should see that we have a takeaway, that the interviewer is not going to stop with just that first initial question. There's going to be follow-on questions. If you just try to memorize the step-by-step solution to that particular question, you're going to struggle when the interviewer comes back with their follow-on questions. So you're going to want to understand the conceptual underpinnings behind the OSI model.